Welcome back everyone, Patrick here, moving on to another question dealing with finding an equation given a graph. So we've already gone through a couple of videos where we did similar examples, and I'm going to be following the same process. So if you didn't watch those examples, please make sure you do before watching this one. And if you're watching this on YouTube, you can go to the website, the link is in the description box, and all the videos are in a certain order. So starting with this one over here, notice that we're given a vertex at 1 and -9, and then we're also given this point. It's actually an x-intercept. It's at 5/2 and 0. So notice that we're actually given a fraction here to work with, and we haven't done that yet and thought I would include it just in case you run into something like that. The algebra, the process is still going to be the same. It's just going to be a little bit more tedious in terms of the algebra. Now what I'm going to do is I'm actually going to write out these characteristics here, and then I'm going to erase the graph. I feel like I'm going to need a little room for the algebra in this case. And by the way, sometimes you may get a question where they won't give you a graph, but these characteristics can be written in words. So they'll say like a vertex is here, and then the graph also passes through this point, like that. So different formats, the same kind of question can be given in. So from here, if we're given a vertex as one of the points, remember we always want to use the vertex form for finding the equation because we automatically get the h and the k value. So in this case, the h value is 1, and then the k value is -9. So all that's left to solve for is this a value. So if we plug in the h of 1, we'll have x minus 1 squared, and then we'll have -9, like that. And so from here, solving for the a value, the way we do that is we take that other point and then plug it in for x and y. So we plug in 0 for y, and then we plug in 5/2 for x, then we got -1, that's going to be squared, -9. So just be very careful with your algebra here. Now the -9, it's not attached to this. Notice these are multiplying, so we can't just split stuff out, but the -9 is by itself, so we could bring it over. So 0 plus 9, we'd have 9 over here. Now what's 5/2? We got to work with the bracket first. What's 5/2 minus 1? Well, that's like 1/1, and then if we get a common denominator, it'd be like 5/2 minus 2/2, which would give us 3/2. Right? Or it's like 2.5 minus 1, which gives us 1.5. But sometimes the fraction is not going to be this smooth, like 2.5 and 1.5, right? So let's keep it in fractions, so we end up with 3/2 in this bracket, and then that's going to be squared, like that. Now, whenever we have a fraction to an exponent, just in general, a little review of exponential rules, we could take the numerator to that exponent, we could take the denominator to that exponent. So what we can do here is we could take the 3 to the power of 2, we could take the 2 to the power of 2. And so what we would end up having is, let's continue this here, we'll end up with 9 equaling a times 3 to the power of 2 is 9, and then 2 to the power of 2 gives us 4, like that. And then we just have to solve for this a value. So a couple of different ways we can do this. We've done this in previous units, but just to do a little review, personally, if I get something like this, I like to just combine this into one fraction and then change this to a fraction. So I'll have 9/1 equals 9a/4, right? This a is like over 1, so a times 9 gives us 9a, 1 times 4 gives us 4. And from here, we could just cross multiply. So we'll have 36, 1 times 9a gives us 9a, divided by 9, a would be 4. That's one way. Another way is we can just divide both sides by 9/4. So we'd end up with 9/9/4. Now this way sometimes can be confusing to students. It's not too bad, right? So we're just dividing both sides by 9/4. Like pretend there was like a 5 here instead. We'd have 5a equals 9. We divide both sides by 5 to get the a by itself. Same thing here, this is just a number. So we divide both sides by that number to get the a by itself. And then the 9 divided by 9 over 4, it's like 9 over 1 divided by 9 over 4, which is like 9 over 1 times 4 over 9. These cancel out. 4 over 1 gives us 4. Right? So that a value is just 4. So whichever way you do it, a is 4, and we're done. So from there, we just have to plug in the a value. Actually, we could just plug it in here. Right? The a value is 4. We got all of our transformation values, and that right there ends up being the equation for part A. So notice there's a vertex at 1, -9. And then you can do the algebra if you want. So 5 over 2, if we plug it in here, 5 over 2 minus 1, which is like 5 over 2 minus 2 over 2, which would give you 3 over 2 in the bracket, to the power of 2 gives us 9 over 4. 9 over 4 times 4, notice that the 4s would cancel out, so we'd end up with 9 minus 9 would give us 0. Okay, so that ends up being the answer for part A. And then finally, moving on to part B, we have a vertex at -2 and 1, so that's the h value. We got the k value of 1. And then we just got to solve for the a value. We'll use this point to a -19. So we'll have y equals a, x plus 2, right? Be careful here. We always switch the sign because it's x minus h, x minus -2, right? X minus -2 ends up being x plus 2. And then plus 1, like that. Right, the k values. So now we just got to solve for this a value. Let's plug in that point. No fractions in this case. I think the actual a value is going to be a fraction, but the point we're working with is not a fraction. Give me a sec here. Right? Yes, like that. So from here, the bracket, 4 to the power 2. Let's bring the 1 over, so we'll have -19 minus 1, right? We could bring this over because it's by itself. And then we'll have a 16, -20, divide both sides by 16. So we'd end up with a equaling -20 over 16. And then that fraction can simplify, divide the top by 4, divide the bottom by 4. And we end up with -5 over 4, like that. Right? So from here, that's just the a value. So this here, we'd end up with y equals -5 over 4. That ends up being the equation. Right? So we end up with a fraction for the a value. Now, just as a quick review from transformations, just because it's a fraction doesn't mean it's a compression. In this case, 5 over 4, that's 1.25, which is greater than 1. So it's actually a vertical stretch by 5 over 4. And then the negative, there's also a reflection, or it opens downwards. But anyway, that's not even part of this question, but thought I would mention that. So a couple of examples where you can get a fraction for the a value. We didn't go through a case like that in the previous videos, and sometimes the point you're given, it's not always going to be a nice point with integers. Sometimes there may be fractions.